Okay, 6.1 key features of exponential functions. Okay, so an exponential function first is, just to remind you, has an exponent in the power. That is an exponential function. Okay? So we're going to talk about, I think we've graphed exponential functions already before, if I'm not mistaken. But we're going to graph this one. So we're going to start, we'll just make a little t-table. So here's the x. And here's the f of x.
Why can't we just say y?
Because it's a function. And that says f of x. It doesn't say y. So that's y. Okay, so we have to have some negative numbers, some positive numbers, right? And these are going to be powers of 2. So what negative number do you want to start with?
4.
Okay, so negative 4. Then how about negative 2, 0, 2, 1? Does that work? Or 2, 4?
Yep.
Because if I do symmetrical on my x, if the graph is symmetrical, I might be able to see it, right? Okay. Well, if I have 2 to the negative 4th, what does a negative exponent do? Reciprocate, so it's 1 over 2 to the 4th, which is what?
1/16.
1/16. Small, right? So 2 to the negative 2 is what? 1 over 2 squared, so it is 1 over 1 1/4. Okay, 2 to the 0 is 1. Good job, that was quick. 2 to the second is
4.
and 2 to the 4th is 16. So it isn't symmetrical, is it? Mm-mm. So okay, so 2 to the negative 4 is 1/16. So that's pretty much like down there. It's not touching the x-axis, but it's close, right? 1/4 at 2. So not much up. And then what is it at 0?
2.
Nope.
No, sorry, 1.
1. And at 2 it is 4. And at 4 it is 16, right? So this thing looks like what? That, right? So think about this. What is every exponential function, unless I moved it left or right or up or down, what's it always going to go through?
No, 1.
It's going to go through 1, right? Because anything to the 0 power is what? 1. So that isn't the parent function, but the parent function would be like, well, it pretty much is, because 1 isn't an exponential function, is it? Why not? What's 1 to any power?
1.
1. So it's not exponential, is it? So this isn't the parent function exactly, but is it pretty close?
Yeah.
Yeah. So what is its domain?
Domain's the x's, right?
Mm-hmm. And what'd you say, Alex?
All real numbers.
All real numbers, because there's no restrictions on what I can put in there, is there? No. Okay. Next thing is, what's the range?
160.
What's the smallest? Am I ever going to get to 0? No, but could I be like 1 over a million? Yeah. So y is greater than what? 0?
Mm-hmm.
It can't be equal to, can it? No. Intercepts. Well, x-intercept is what we usually talk about. Is there an x-intercept?
No.
Nope. Is there a y-intercept?
Yeah.
What is it?
1.
Y equals 1. Or you could put 0, 1.
That's what I just put.
Yep. And that is because anything to the 0 power is what? 1. Asymptotes. Vertical asymptote?
Right.
Vertical is up and down. Is there a vertical asymptote? Guys, if the domain is all real numbers, is there a vertical asymptote?
No.
No. Because domain and vertical go together, correct? So there's none. What about a horizontal asymptote?
0.
0. So y equals 0. That one we should write y equals 0, shouldn't we? I'm going to get rid of this y equals 1 over here because that would be an equation of a line, wouldn't it? And the intercept is definitely not a line. And end behavior. So end behavior. Where does it end? Up. So where does it start? Does it start down?
No.
No. It kind of goes like that.
Yeah.
But that's weird, right? We're not going to write it like that. So we're going to write EB. And I'm just going to go with 1. Doesn't say up, does it? No, it just says 1. So if I wanted the parent function, I'd have f of x equals, they usually I think put b to the x or a to the x or something like that. Okay. So, but can I move this left and right? Yes, just like anything else we've done. Can I move it up and down? Okay, what do I have to add in there to move it left and right? Left and right. What variable moves it left or right?
K. H.
H. Left or right is horizontal,
Yeah, H is
right?
horizontal.
And so it'd have to be on the x, wouldn't it? Okay, so I'd have x. And how you write this is a, b to the x minus h. And then how do I move it up or down? Plus,
H.
okay.
Oh,
H.
I thought you meant left or right.
No. So, well, we know H goes what? Left or right? Opposite direction, right? We know K goes what?
Up and down.
Up and down. Most of our graphs we've done 0, 0, haven't we? But guess what we're going to do here?
0, 1.
0, 1. So we're still going to move it up or down, left or right. We're still going to reflect it over the x-axis. And we're still going to do all of that stuff, but it's just this shape. Didn't I promise you HK would always do the same thing? Keeping to my promise. Question before I go on further. So this is our basic standard form, right? What does H do? Left and right, correct? What's K do? Up and down. And what point are we moving left and right, up and down?
0, 1.
0, 1. So we'll take 0, 1, and we'll put 0 plus H, comma, 0 plus K. And if they're positive or negative, that would be a negative or positive, right? Okay. So what's going to happen here? Something. What's the 5 going to do to it?
Distribute?
Well, you can't distribute into an exponent, but just in general, what's the 5 going to do to the graph?
I don't know.
Bigger.
It's going to, every answer you get, it's going to multiply it times 5, isn't it? So is it going to make it bigger faster or bigger slower?
Bigger, fast.
Bigger faster. So instead of being wider, it's going to be like, but we don't know what the 1/2 is going to do we?
No.
Okay, so we're going to have to figure all that out. So we want good numbers, don't we?
Yes.
Yes. Can you see this purplish gray? Okay.
Yeah.
Okay, so I have x and I have g of x. So we got positive and negatives. Do you want to stick with -4, -2, 0, 2, 4?
Sure.
Everyone okay with that?
Are we gonna do the four stuff?
Huh?
Are we gonna do them by fives and not twos?
Well, we're having to take 1/2 to a power.
Oh.
Yeah. So any power we get, 5's not going to go into it anyway. So it's, yeah, it'd be good to pick some good numbers, but I don't know. There's not really any good numbers, is there?
Mm-hmm.
That is a good thing to think about. She's like, are we going to with that 5? Well, if we could get, like if I had a 3 down there, we'd want to pick like things that we try to get a 5 to go into, right?
Mm-hmm.
But we're going to have an even denominator and an odd numerator. That's not going to work for us. Okay, so we already know, what does the negative do to it? The -4. What's the negative exponent do?
Reciprocate.
Reciprocate it. So it's not going to be 1/2 to the -4th. It's going to be,
1/2 to 1/4.
well, it's going to be 2 to the, let me write it. I lost you. So it's 1/2 to the -4th. Yes? And the negative reciprocates the 1/2. So it's 5 times 2 to the 4th. Brandon, this way. Why aren't you guys writing? Okay. Ooh, that's going to be a big one, huh?
Yeah.
So 16 times 5?
I thought it was still 1/4.
Huh?
I thought it was still 1/4. Or is it just to the fourth?
It's to the 4th.
The half would reciprocate.
The half would reciprocate, not the 4. Okay, so 16, so that'd be 80. Did I do that right?
Yeah.
That's going to be big. That 5 did what with it? Shot it clear up, didn't it? Okay, so then I'm going to have 5 times 2 to the what now? Second? Because the -2 reciprocated it and then became positive. So it'd be 20. Now I'm going to have 5 times 1/2 to the 0. Well, anything to the 0 is 1, so the answer is just 5. Am I going too fast?
No.
So now I have 5 times 1/2 squared. So that's 5 what? Fourths? So what's the next one going to be? So it'd be 1/16, right? So it'd be 5/16. Pretty small, isn't it? Okay, -4 was 80. As I clear up there, right? -2 was 20. Well, if that's 80, that I don't know. Not to scale, right? Actually, that 4 needs to be clear up that I can't even mark it, can I? Okay.
Unless you move the graph down.
Yeah, if I would have moved the graph down, I would have been in better shape, right? And then I've got, well, at 0 it was, what is it now? 5. No, wait a second. I thought 0 was always going to be 1. What made it 5?
1 times 5.
The 5, right? That 5 changed that. And then I have 5/4, so that'd be 1 1/4, right? And I have 5/16 would be like clear down there, wouldn't it?
Yep.
Yeah? So what's this graph look like?
Weird.
Was it the same general shape? If I could graph right?
It looks a little swiggly. So.
There. I made it better. You know what's nice about a sketch?
Doesn't need to be perfect.
It doesn't mean to be perfect, and you just erase it, and you just add your dots back, and the world's all good. See that? There we go. Is it the same general shape?
Yeah.
Yeah, it looks probably a little straighter because that 5, but it's reflected over what axis? The parent function went like this. Yes? So it's reflected over the what? The y. I could reflect it over the y without a negative exponent.
Sweet.
So they call this graph a decay graph. Why do they call it a decay graph? What's happening to the amount?
Dying.
It's
down.
going down. So when the base is between greater than 0 but less than 1, okay? So that's a proper fraction, right? Greater than 0 but less than 1. It is a decay function or a decay graph. Yes?
When you flipped it, you have the arrow at the top. Why do you have it at the top instead of at the bottom?
Well, technically they're both places, yes?
Yeah.
But we go left to right. So this one is growing and this one is what? Decaying. And when the base is greater than 1, it is a what?
Growing.
Growth. Is this important to know?
No.
Yes.
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 Now, I got that reflection without even using a negative. Could I use a negative and still get the reflection?
Yeah.
Yeah, but it's easier this way. Everyone ready for me to go?
Yeah.
Okay, so this is just what I've already put in. I just said, is everyone ready? You've got to speak up.
I didn't do the domain or anything.
Oh, well, I didn't do any of it. You guys want to do the domain and range?
Yeah.
Okay, domain,
All the numbers?
all real numbers. Range, remember, it's not this one.
Is it
Am I ever going to go below 0? No. So y is greater than 0. There wasn't an x-intercept, and I didn't move it up or down, so is there going to be an x-intercept? No. Once I move it down, is there going to be an x-intercept? Yeah. So there's just a y-intercept. I'm only, when it says identify the intercepts, guys, you can write x, y, and write none if you want, or just identify what it is, okay? So what's the y-intercept? 0, 5. Because it's always going to be the x is 0, right? Vertical asymptote? None. Horizontal asymptote?
5? Is it 0?
It's 0. Y equals 0. Again, if I move that up or down, would that affect the horizontal asymptote?
No.
Yes. And end behavior, where's it ending?
Down.
And when we say down, we got to know it's not going past the x-axis. It's like it's doing this, right? With these, I hate when they ask end behavior because I'd rather just sketch the graph. Okay. Now are we good?
Yeah.
Okay. So this is just a picture. You've already written all this stuff.
Yeah.
Okay? The left is a what? Growth or decay?
Cool.
Growth, because it's going what from left to right? Up. Going up. The right is a decay. Now, they wrote AB to the X. I should have written AB to the X before. I wrote an A on the very first slide, didn't I?
No.
No, I didn't. I wrote B.
B to the X.
Okay. So H moves it what way? Left and right. K moves it up and down. If B is greater than 1, it's a what kind of a function? Growth. If B is between 0 and 1, it is a decay.
Should we write this down?
Well, you've already written it down.
The B greater than 1.
Didn't you already write? It was on the last slide.
write it down.
Oh, you didn't. You should write that down. So if I had 2 points, could I write this equation?
Yeah.
Yeah. Because, let me get a brighter color. This would be my H and my K. And this is 1 comma B, but that would be an X and a Y. And could you plug it in and figure it out? Yep, should be able to. Now you good? Okay, graph. Identify what's going to happen. Now, we're not going to make a table. Not going to make a table. We're going to go through our reasoning. Get what I'm saying? So we're going to go through our f of x equals a b to the x minus h plus k. And we're going to move it around.
So, can we use a table around
Well, you can, but I want you to reason through it. That would be, I mean, it's a sketch, right? We know the parent function goes through what? Where does the parent function go through, guys?
Like what point?
Mm-hmm.
0, 1.
0, 1. Trying to get it. Okay, so we know it goes through 0, 1, and it looks like this, doesn't it? Okay, so that's the parent function. 3 is my base, yes. So it's probably going to turn a little sharper than 2, right? Okay, what's this negative going to do for me?
Make it go good.
So it went this. The negative a reflects it over the x-axis, doesn't it? Okay, so instead of going through 1, 0, it's going to go, 0, 1, it's going to go through 0, negative 1. Because of what?
The negative.
That negative. Ooh, that's pretty thick. Oh, I used the wrong tool. Because of that negative right there. Is anything else going to really change?
No.
No. So I'm going to sketch my graph now. So it's going to go right up next to my x-axis and then come where? Down. Now, if I had 2 on there, it'd go a little bit this way, wouldn't it? Yes? And if I had 6, it'd go like that. So that's... So it wants to know my domain, my range, my intercepts, my asymptotes, and end behavior. So my domain is what?
All real numbers?
All real numbers still.
Are we going to get one that's not all real numbers?
Not unless it's an application problem, no. Range,
Y. Less than 0?
Mhm.
Yeah.
y is less than 0.
Will it ever be greater than, like, equal to?
No, it can't be, because is there any exponent that's going to get you 0?
No.
No. Now, I guess I shouldn't say that. Okay, it's never going to be just 0, but if I move that up or down, does that make sense?
Yes.
If I move the graph, but you're never going to get 0, because you can't ever get 0 unless you minus 1. Okay, so then we need intercepts. Do we have an x-intercept?
No.
Okay, so x-intercept, none. Y-intercept, Yeah, 0, -1. Yes.
You said the range would be less than 0, not
Oh, yes.
0?
Yep. Good? And then asymptotes. Okay, do I have a vertical asymptote?
No.
No. Horizontal asymptote.
0?
Y = 0. Doesn't say which side of 0 we're on, but are we going to hit 0? Oh, and behavior. Basically, is it increasing or decreasing?
Decreasing.
Decreasing. So you can just do
What is FBC?
N behavior. EB.
Oh. It's
EB. Questions? Concerns?
No. How many more do we have?
I don't know.
Oh.
What's happening to that?
It goes
Is that an H or a K?
K.
It's a K. So what's it do to it?
Down.
Down. K goes down 4, right? So it's the same graph that we just had. So we just did, let me, oh no it isn't. This one's not reflected, is it? What?
Where's the H then?
The H would be up with the X. It would be in the exponent.
Yeah, I know, but since there isn't one or whatever.
So then it's 0.
0.
Mm-hmm.
Okay.
Okay, so our point was 0, 1, yes? And it's going down 4, so is that on the 0 or the 4? I mean the 0 or the 1, sorry.
The 1.
The 1. So minus 4. So 1 minus 4 is what?
-3.
So 0, -3. So we're going to go down to -3, but we're not going to go down, we're going to go what? Up. So where is our new horizontal asymptote? It was, horizontal asymptote was at y = 0.
Yeah.
Now where is it? Because it went down what? 4, so it's y = -4. Because you just subtract 4, don't you? So our new asymptote is where? Or our new axis is where? -4?
Yeah.
So now it's just going to go like this, isn't it?
Do we know what the x-intercept?
No, we don't. We probably should find it, shouldn't we? If we can. Should we do it if we can?
Yeah.
Yeah? So we find an x-intercept by setting the whole thing equal to 0, right? Because the y would be 0 on an x-intercept. So we'd have x int. Oh, this was the y-intercept, wasn't it? Okay. So we'd have 0 = 3 to the x minus 4. So if I were to solve that, I would add 4, wouldn't I? Would I add 4?
Yeah.
Yeah. Oh, is 4 a power of 3? Nope. You don't know how to solve that yet. So you can't solve it yet. But should you check? So what if I had 3 = 3 to the x? That would be a what? A 1. So your x-intercept would be 1, right? What if I had 9 = 3 to the x? It'd be 3 squared = 3 to the x, so x would equal what? 2. But 4 is not a power of 3, so do I know how to solve that yet? Nope. So we tried. Move on. So we got a graphed domain.
All real numbers.
All real numbers. Range.
-3.
Y is greater than -4. Where is that new horizontal asymptote? We have our horizontal asymptote. Does it have a vertical one? None. We tried to find the x-intercept and we got it broke down to here.
What about the y?
The y-intercept's here.
Oh, yeah.
And all we need is end behavior. Is that right?
Yep.
Is up. It's increasing. I think you're ready for one on your own.
Oh, God. Are they gonna be? Whoa, not that one.
No, what is that?
That's horrible. That's disgusting. That's what that is. Oh.
That's rude. Okay, what is that plus 3?
H.
It's an H. So is it going to go right or left?
Left.
It's going to go left 3. Why is it going to go left, Emma?
I don't know.
Because it's a plus. Okay, so try that one on your own. Okay, so how I would approach this problem is 0, 1.
Up to the right.
Okay, this is going left 3, yes?
Uh-huh.
So that's minus 3 on the x. So it's negative 3, 1 now.
Oh. Yeah. I forgot about the one. Right. I just have my point wrong.
Okay, so then, oh, I gotta get some.
Ooh.
Okay, so I'm gonna go negative 3, 1, and that's where my crook is gonna be now. So my graph is gonna, because it was like this, yes? Now it's gonna go like this. Okay, so we need to figure out a y-intercept. Well, how do you figure out a y-intercept? You plug 0 in for x. So x-intercept is none, right?
Well, nowadays.
But y-intercept would be 5, 0 plus 3,
So we 5 cubed.
5 cubed, which is,
125.
so the y-intercept is 0, 1, 25. See how I didn't cross that y-axis? If I would have crossed it, I would have had to put 125 there.
Ew, that's disgusting.
That is, but you don't have to graph it, do you?
Thank goodness.
Okay, domain?
I put x such that x is less than negative 3.
All real numbers still.
Oh, yeah. Because I put it was on the x-axis.
Okay, exponential functions are always all real numbers until you get into an application problem. Okay, these are used for growth and decay. They're used for money and chemicals and things like that. Can you have 0 time? No. Like, can you have less than 0 time? No, ever. So your domain would be greater than equal to 0. Does that make sense? So until you get in an application problem, your domain is always going to be all reals.
Okay.
Range. Did it go up or down?
Up.
No. Did the graph move up or move down?
Up.
No, it did not. It moved left and right. Did it move up or down? No. So y is greater than 0. Vertical asymptote? None. Horizontal asymptote? Y equals 0 because it didn't move up or down. And behavior?
Up.
Up.
I got that one right. I got the y and
So are these just going to start combining all these things? Yes. Okay, what's that going to do? What does a negative x do? Reciprocate it, so it's not going to be growth, it's going to be
Okay.
decay, but it's going to be a different kind of decay. Oops. It's going to be one, instead of this, it's going to be what?
down.
And it's going to not go through 0, 1, it's going to go through 0, negative 1. Is anything else going to happen to it? No. Domain is still what?
Whoa. All real numbers.
All real numbers. Range,
Will be
y is
less.
less than 0. Intercept, x-intercept?
Hold on.
None. I'm just stating facts we already know, right?
Whoa.
Y-intercept? 0, -1. Asymptote, vertical asymptote.
No.
None.
Zero.
Y equals 0. And end behavior.
Yeah.
And why did it go down?
Because
Because the negative exponent, right? So as you graph these, you're not supposed to be doing an XY table, are you?
no.
You're supposed to be just using what you know.
Come on, we don't have to use the table.
I didn't mind. Do we have to graph it on our homework?
Yeah.
Okay.
Okay. Writing an equation. So we need to write an equation. So it was a b to the x minus h plus k. So we need to know where the vertex is, or that anchor point, which is 0, 1, isn't it? So this is h and this is k.
How do we figure out?
Oh, but what?
How do we figure out what B is?
Okay, well, we have to find a good point. Right here? Looks like
1.
1, 4, you mean?
Yeah.
Right here? And we're going to plug it in. Okay, so we're running out of time today. I'm going to go print your worksheets real quick so you have them to start. We'll have to finish writing equations tomorrow. So you do what you can. Got it?
Okay.